Hey, welcome back to Math with Patrick. It's May 6th, and we have problem number 126 from this Daily Epsilon calendar to solve right now. And the answer apparently is 6. I guess we should show why this x right here is supposed to be the number 6. Okay, so it looks like we have a parallelogram. I see that we have two pairs of congruent angles, and in this setup, I know that we have some kind of parallelogram. Let's just, I guess, prove that it is a parallelogram real quick. And then once we know it's a parallelogram, we can do some stuff with it. This kind of looks to me like we have that like parallel line and transversal situation, where once we do this, we basically have four angles that are all big. So these four angles are all going to be the exact same in measurement, and they're all kind of the big angle. And then we're going to have four angles that are all the small angle. And then one way to confirm that these are all the same, this pair right here, these are called vertical angles. And so anytime you have like two straight lines, the opposite angles are always going to be congruent. This picture has a lot of symmetry in it. Maybe if I actually make my lines parallel, I'll try my best. Oof, I'll just leave it as is. You could maybe see how like this angle corresponds with that one in the diagram. These are called corresponding angles. Those are congruent as well. Let me see if I can do this one last time. Ooh, that was wobbly. Oh well. And basically, if we just kind of extend this idea of parallel lines, so I'll just claim that these lines are parallel real quick, then we have just a whole bunch of these parallel lines and transversals. So these four are all going to be the same size as the big ones from over here. These ones are all going to be the same size as the small ones from over here. And you can kind of tell that in the middle, we have some kind of parallelogram right here. And the main thing that I wanted to prove is, I guess, firstly, the opposite angles, like the ones that I guess would form some kind of diagonal in the parallelogram, those ones are going to be congruent to each other. We kind of already know that from the problem statement here. These sides are going to be congruent to each other. That's also what's in the problem statement here. But I just wanted to make this link that, hey, we're working with a parallelogram here, even though they didn't actually give us these parallel lines to begin with. You can kind of do stuff with angles to figure out that you do indeed have parallel lines. The important thing here is, if you notice in this diagram, any red-green pair is going to sum to 180 degrees. It doesn't matter which one you pick. These ones are pretty obvious to me because they form a straight line together. And, all the way around a circle is 360. So halfway around a circle is 180. And then that's kind of where you get this idea where a straight line is 180 degrees. And so if those red-green pairs are clearly 180, or when you add them together, they equal 180 degrees, we could do the exact same thing in our diagram over here. Specifically, since we're solving for x, I can add these two together and then say that they are supplementary, or they add to 180 degrees. What's kind of funny is that this stuff doesn't matter at all. We don't really need to care, for this calendar at least, what z and what y are, but just for the sake of it, why not? Let's solve for all of the variables today. Let's solve for x first, because that's what we should do. I know that 10x plus 25x minus 30, they're going to equal 180 degrees together. I mean, I guess I should put little degree marks around everything because these are angle measurements, but it just feels kind of tedious. I'll combine my like terms. I have a 35x, and I'll also add this 30 at the same time. That's going to give me a 210 on the right side. Now I just need to figure out how many 35s fit into 210. We could just count up by our 35s. It's not that bad. 35, 70. And then at this point, you can kind of tell that it's going to be 6 today because I want to count by my 70s now. It'll be a little bit quicker. And I can reach 210 once I count up 6 35s. Okay, cool. X is 6. We're all done. Because 35 times 6 is 210. Cool. There we go. And then just to solve for the other ones, just to learn a little bit more about this diagram, it looks like this angle right here has to be 60 degrees because it's 10. Ooh, that's not a parallelogram. Let me try again. 10 times x, and x was 6. So this one was 60 degrees. That means that this one was 120, but let's just double check. If we plug in a 6 here, we get 150. Yeah, and then minus 30, we get 120. So this angle right over here is also 120 degrees. And so I know that 1000z is going to be equal to 120 degrees. We could divide both sides by 1000 and then simplify this fraction. That's going to be 12 over 100, 6 over 50, 3/25. Okay, there it is. So z is 3/25 today. And then finally, this expression with y in it has to be equal to 60 degrees. So 5y plus 45 is equal to 60. And then I can just kind of tell that this number has to be 15. And then once you divide both sides by 3, you get, divide both sides by 5, you get y equals 3. So those two numbers didn't really matter. Like the calendar really just only wants you to solve for x and then confirm that it matches today's date. But I figured, why not? Let's just run through it all and figure out what all of our variables are. So that's the whole problem. We're all done, and I'll see you tomorrow.